Hi everyone, I welcome you to my fourth lesson about differential equations. My followers all over East Africa, I send you greetings. I remind you about what we have so far covered. In our first lesson, we introduced differential equations and went ahead to form differential equations. In the second lesson, we talked about some of the methods of solving differential equations, and basically that was by separation of variables. In the third lesson, we talked about homogeneous equations where we make use of the assumption y is equal to v of x. In our lesson today, we are going to talk about linear equations. Linear equations. Okay, and we are going to make use of the integrating factor. Integrating factor. So what is a linear equation, and why do we make use of the integrating factor to solve linear equations of the first order? As always, let us first talk about what we have discussed so that this is made clear. Okay, remember in the first lesson, in the second lesson we talked about equations of the form dy by dx is purely a function of x. We say this is by direct integration. Then we talked about equations of the form dy by dx is a function of x over a function of y, or it is a product of the two, function of x times function of y. And we say that this is by separating variables. Then we talked about dy by dx is both a function of x and y, okay? But x's and y's cannot be factored out. Not to be factored out, okay? Now here there was a condition. If all the terms involved they have same power, have same total power, okay, then we make use of substitution y equals to vx. Now let's look at this type of equation. You consider the equation dy by dx plus 5y equals the 2x. Okay, this we have not dealt with it before. When you look at it critically, it is a different type of equation which we want to discuss today. Okay, this equation is called a linear equation of the first order. The reason why this is called a linear equation, you know, when you go ahead and study mathematics, we can write this y plus 5y equals to e to power 2x, okay? And it looks like this looks like like a linear polynomial. Okay. Remember, this is the same thing as the y by dx. In mathematics, when you go ahead and study calculus and study differentiation, whatever, you discover that y with a dot is the same thing as the y dx. So when you look at it, y plus 5y is equal to e to the power 2x, it looks like a linear polynomial, and therefore these are called linear equations. And to solve linear equations, we need to make use of the integrating factor. Okay, so let's write something about this so you get to understand it much deeper. So a differential equation of the form dy dx plus py equals to q, where p and q are functions of x, but they can be constants, is called a linear equation of the first order. So this equation is linear equation of the first order, okay, because it is of this form, and therefore these equations should be given special attention. Okay, so how do we solve these equations then? If they are equations of the first order and they are taking this form, how do we solve them? So to solve these equations, we make use of the integrating factor. These are the equations I'm talking about. Okay, dy dx plus py equals to q, where p and q are either functions of x or they are constants, or one is a function of x and one is a constant, whatever. Okay, now to solve them, we need to make use of the integrating factor, and the integrating factor will always be e to the power the integral of p by dx. This is the integrating factor. Sometimes they can call it if. So the point, integrating factor. So for you to be able to solve those equations, you need to make use of the integrating factor. Now let's consider our equation. Consider dy x plus 5y equals to e to the power 2x. And we try to see if we can get the integrating factor. So here, it means that if you compare with dy dx plus py is equal to q, this means that p equals to 5. That's the coefficient of y. And the q is e to the 2x. Now, the integrating factor, okay, will be equal to e to the power 5 by dx. And this is simply e to the power 5x. So what do we do with this factor? We multiply through the equation by the integrating factor. Okay, and if you multiply through by the integrating factor, what do you get? Okay, we shall have dy by dx multiply through by e to the 5x plus 5y multiply this by e to the 5x will be equal to e to x multiplied by e to the 5x. Let's try to simplify this. We have dy by dx, okay, times e to the power 5x plus 5e to 5x, multiply this by y equals to e to the 7x. When you're multiplying numbers of the same bases, we said in indices, if you're multiplying numbers of the same bases, you add the powers, and here you get e to the 7 of x. Okay, now why do we multiply through by the integrating factor? This integrating factor has the effect of converting the left-hand side into an exact differential or a complete differential. So the left-hand side will become d by dx. Actually, it's the same as the integrating factor, which is e to power 5x times y, okay, will be equal to e to the 7 of x. If you have done differentiation so well, and remember your product rule, you keep one factor constant and differentiate the other, okay? If I keep, let me try to consider d by dx of e to the 5x times y. This is e to the 5 of x, okay? Remember our product rule, we keep e to the 5x constant and differentiate y, we end up with y by dx, plus you keep y constant and differentiate e to the 5x, you get 5e to the 5x, which is the same thing. This is the same thing as what we have here, okay? That is the same thing exactly, because this integrating factor, it has the effect of condensing the left-hand side and it becomes an exact differential, okay? So we are having y of e to the 5x times y is equal to e to the 7x. Now integrating both sides. Integrating both sides. What we get? We get d by dx of e to the 5x times y will be equal to e to the 7x. But we want to integrate both sides with respect to x. Okay, with respect to x. What do we get? So this d by dx of the bracket shows we are differentiating, and then this the integral sign and dx show that we're integrating. But you know, integration and differentiation, they're exactly the same, but one is the opposite of the other. So when you're integrating and differentiating at the same time, you just end up with the function. There is no effect. You end up with your function 5x times y is the integral of e to the 7x by dx, okay, and e 5x, okay, times y will be integrating an exponential function. Remember, we write the exponential function and then differentiate the power and divide n plus a constant, okay, and now this is the solution to our differential equation. The y dx plus 5y is equal to e to the 2x. That's now the solution. We have done it by the integrating factor. Now there is a point which must be emphasized when you're talking about this. Okay, we say that the integrating factor is e to the power p by dx, and in this case our p was equal to 5 in that example we have just solved. So when you look at the integral of 5 by dx, you are supposed to get a 5x plus c. But we don't write that constant of integration if you are keen. Why did we leave it out? Let's try to see and learn this. Okay, suppose I keep my constant. I will have the integrating factor will be equal to e to the 5x plus c. And you know, in indices, you add the powers when it was a product of numbers of the same base. So this is e to the 5x times e to power the constant. Now, if you multiply through by the integrating factor, everywhere by the integrating factor, let's look at this step. Remember, we had our dy by dx plus 5y was equal to e to the 2x. So let's multiply through by the integrating factor with that constant of integration. Okay, we have dy by dx multiply through by e to the 5x times e to the c plus 5y multiply through by e 5x, then e to the constant is equal to e to the 2x multiplied by e to the 5x, then e to the constant. Now this e to the constant, okay, we'll factor out on left hand side and you end up with dy by dx times e to power 5x plus 5y times e to power 5x will be equal to e to power 2x multiplied by e to the 5x, okay, multiplied by e to the constant, okay. Now this e to the constant is common on both sides and it cancels out. In the end you have dy by dx, okay, times e to the 5x plus 5y times e to the 5x will be equal to e to, let me write this as 7x. So when you add a constant of integration after integrating the p, that constant disappears, it cancels out on both sides because it factors out and it cancels out. So in this case, to avoid all this, we leave out the constant when we integrate the p with respect to x, okay? That's why I left it out, okay? So let me write for this information. I know, students always forget a lot. Let me write for this information. It will help you out when you are revising. So we are noting that in determining this integral p by dx, we do not include a constant of integration, okay? And that omission is for convenience because that constant factors out and cancels. So if you want, okay, you can always include, but you're going to take too much time. And at the end of it, you will factor it and cancel it out. Okay, so it is one of the cases, the rare cases where we don't include a constant of integration. So we multiply both sides by the integrating factor, and the integrating factor will always be e to the integral of p by dx. Okay, always equation is of this form, dy by dx, okay, plus py is equal to q. They are called the linear equations of the first order. And if you have to ever solve such equations, you got to multiply through by the integrating factor. This integrating factor will always convert the left-hand side into a complete differential, okay? And therefore, the only task we shall have is to integrate the right-hand side, okay? Yeah, let's keep summarizing this for purposes of reference and future use. So this is the general result. Let's summarize it and we start solving some problems about this. We said over dy by dx plus py equals to q, okay? The integrating factor is e to the integral of p by dx. It is multiplied on both sides and you have d by dx of y times e to p by dx, okay, plus p y times e integral of p by dx equals to q times e to the integral. Oh, sorry about that. Let me try to erase this. Okay, to the integral of p by dx. So we say that the left-hand side always becomes a complete differential. It is going to be d by dx of y, then e integral of p by dx. It condenses to this, and this is going to be q times e, the integral of p by dx. So when you integrate both sides, you have d by dx of y times e integral of p by dx. Okay, with respect to x, this is going to be the integral of q times e integral of p by dx. Okay, with respect to x. Now it looks a bit complicated when you look at it, but it's simple and you don't have to come this now. I'm just including it just for reference. Or if you want, integration, differentiation on the left hand side cancels out and you only end up with the y times e integral of p by dx will be equal to the integral of q times e integral of p by dx with respect to x. Or you may say that y times our integrating factor, okay, will be equal to the integral of q times the integrating factor with respect to x as just a general result. Okay, this is general for all linear equations of the first order. Okay, that will always be the formula, but we don't need to cram the formula. No, always work out, from first principle. You get a deep understanding of what you are trying to do. So I've included this just for reference, okay? Or if this happens to be part of a longer question, you can just quote it and write the answer. But we don't always encourage, cramming formulas, and it's not good. You will not learn any mathematics, okay? So that is it basically about this. And we can now go ahead and solve some 2 or 3 problems. And then we shall be able to solve differential equations with all the methods. So let us look at this example. They want us to solve x dy by dx plus y equals to x cubed. Okay, the equation is solved. X times dy dx plus a y equals to x cubed. Okay, now if we had solved this question, we must really understand the form we are dealing with. This is a linear equation, but we know that our linear equation is dy dx. Okay, so we know that for dy by dx plus dy equals to q, okay, we shall have the integrating factor as equal to e to the power the integral of p by dx. But when you look at the equation that they have given us, it's not exactly like this, but we can, try to write it in this form, okay, for this equation. So for x dy by dx plus y equals to x cubed, you can say dy by dx plus 1 over x times y equals to x squared. That's dividing through by x. And this will mean that your p is 1 over x. Okay, so the integral of 1 over x, the integral of 1 over x by dx will be a natural logarithm of x. We say that you don't need to include a constant at this stage because it factors out and it cancels out from both. So we are trying to solve the y by dx plus 1 over x times a y is equal to x squared. That's what we are trying to solve. And we know that we have already got our integrating factor. We are saying that our integrating factor is e to the power integral of p by dx. But the integral of p has given us natural logarithm of x. So the integrating factor, okay, is just e to power natural logarithm of x. And this is simply equal to x. Why? It is simply equal to x. Let's look at it. Let's take log base e of the integrating factor on both sides. Will be log base e of natural logarithm, or no, it is log base e of, let me first wrap this so because I had made a mistake. It will be log base e of e to power natural logarithm of x. Okay, and this is the same thing as using laws of logarithm. Log base e of the integrating factor is natural logarithm of x times log base e of e. But log base e is equal to 1 because the power and the base are the same. That is always a 1. So we have log base e of the integrating factor is, we know that natural logarithm of x is the same thing as log base e. Okay, so here the bases are the same. That means that the powers also be the same. Okay, and therefore we have our integrating factor is just simply equal to x. Okay, so this is a note that you should always take into account at all times when you encounter this. Okay, e to power natural logarithm of any function of x or whatever, you end up with the f of x. Okay, don't forget that it is really so important for you. At some point, this will always pop up and we need to make use of that fact. Okay, so next we go ahead and make the substitution. Okay, we substitute, now multiplying through, okay, our differential equation, okay, by integrating factor. What do we get? We have the y by dx times our integrating factor, which is x, then plus 1 over x times y multiplied by the integrating factor will be equal to x squared times the integrating factor. So this is y by dx multiplied by x plus, okay, y equals to x cubed. Okay, and when you look at this, it condenses to d by dx of x times y is simply x cubed. So integrating both sides with respect to x, you end up with, take away this, okay, you have the integral of d by dx of x y is the integral of x cubed by dx. Remember, we're integrating with respect to x both sides. Okay, so what do we end up with? Let's see. We have the integral b by dx of xy with the integral of x cubed by dx. So here we have with respect to x. So we have x y is equal to x power 4, okay, over 4 plus a constant of integration. And maybe if you want, you can have this as, but this is the solution without wasting a lot of time. Okay, the solution to our differential equation, and we have done it. So let's look at another example, which says solve dy by dx plus 3y equals to e to the 4x. That's an interesting example. Okay, so we want to compare with, okay, compare with dy by dx plus py equals to q. This means that our p is equal to 3. Okay, and if p is equal to 3, then if we integrate, the integrating factor will be e the power integral of 3 by dx, which is simply e to the 3x. Okay, that's what we are getting as the integrating factor. So what next? The next step is just simple. Multiply through by the integrating factor. Everywhere by the integrating factor, we're going to have dy by dx multiply through by e to the 3x plus 3 e to the 3x, multiply this by y equals to e to the 7x. Okay, and you have d by dx of y e to the 3x, okay, is equal to e to the 7x. So what happens is you integrate both sides, d by dx of y e to the 3x with respect to x, with the integral e to the 7x with respect to x. So here we say you end up with y e to 3x will be equal to e 7x over 7 plus a constant of integration, and that's just the solution. Very simple. We have got the solution, ladies and gentlemen. We have more reasons to celebrate. Okay, that is it. That's the solution. So let's look at this. It says solve. What are we solving? 1 minus x squared dy by dx minus xy equals to 1. Okay, so as usual, we shall begin by arranging it into the form where we can pick p and then get the integrating factor. So this means that our dy by dx minus xy over 1 minus x squared is equal to 1 over x squared, or is equal to 1 over 1 minus x squared. Okay, so let's make it more clear. We have dy by dx, okay, plus I write negative x over 1 minus x squared times y is 1 over 1 minus x squared. Now compare this with dy by dx plus py equals to q. It will mean that your p is negative x over 1 minus x squared, and the integral of p, okay, minus x over 1 minus x squared by dx will give us, so integral of p by dx is giving us Now you have to be really very careful with integration. When you look at this integral, differentiating the denominator, okay, produces the numerator. And here, this is going to be natural logarithm of 1 minus x squared. But remember, there is this half. Okay? I don't know whether you understand how we integrate functions where the denominator is the function, the numerator is the derivative. Okay? It will always give us natural logarithm. So differentiate here, you get negative 2x, and 1x cancels out. So negative half factors out and end up natural logarithm. Okay, so our integrating factor will be e to the power half of natural logarithm of 1 minus x squared. So using the laws of logarithms, I can write this as e to the power natural logarithm of 1 minus x squared to the power half. And we say that e to power natural logarithm, then this is going to be 1 minus x squared to the power half. Okay, that is our integrating factor. We have got it. Okay, so what does it mean after getting the integrating factor? So let's go to the next page and the next page. Okay, so the next step is to multiply through by the integrating factor. We have the y by dx multiplied by 1 minus x squared to power a half, which is the integrating factor, plus minus x over 1 minus x squared, okay, times 1 minus x squared to power half, then times y is equal to 1 over 1 minus x squared times 1 minus x squared to the power half. Okay, so next we said, without wasting time, the left hand side is going to condense to I by dx of y times the integrating factor, which is 1 minus x squared to power half. Okay, this is the left hand side. The right hand side, we have numbers of the same base and we are dividing. We end up with 1 minus 1 over 1 minus x squared to the power half. If you really try to work on the powers, that's what you're going to get. So the integral of y times 1 minus x squared to this by dx of y times 1 minus x to power half, then with respect to x is going to be the integral 1 over the square root of 1 minus x squared by dx. Okay, so here we say this is going to be y times 1 minus x squared to power half is equal to, this is a standard integral which goes to the sine inverse of x plus a constant. Okay, so in the end we have the solution as y into 1 minus x squared to power half is equal to the sine inverse of x, then plus constant. Ladies and gentlemen, this is our solution to the differential equations. So you can now go and try as many questions as you want